Once again, I welcome on the class of hydraulic engineering. So today I will discuss the energy depth relationship. And in energy depth relationship, firstly I will discuss the what is specific energy and what is the expression of specific energy for smaller value of bed slope and larger value of bed slope. And after that I will discuss the relationship between depth of flow and specific energy. And also I will discuss the what is alternate depth. And after that I will derive the condition for the critical flow for a given value or for a fixed value of discharge. And after that I will derive the relationship between derive the equation for the maximum discharge possible in a channel for a fixed value of specific energy. So today I am going to discuss about the energy depth relationship. So in energy depth relationship, firstly I will define what is specific energy. So specific energy is the it is the total energy at a section with respect to the channel bed as a datum. So we can write what is specific energy. Specific energy, and it is denoted by capital E. So it is the total energy at a section with respect to channel bed as datum. So this specific energy can be written as Y plus V square by 2G, where Y is the depth of flow and V square by 2G is the velocity here. And total energy can be written as total energy E total is equal to Z plus Y plus V square by 2G, where Z is the datum is depth of flow and velocity head. For small bed slope and kinetic energy, kinetic energy correction factor alpha is unity. Specific energy can be written as Y plus V square by 2G for small value of bed slope. For large value of bed slope and kinetic energy correction factor not unity, then specific energy can be written as Y cos theta plus alpha into V square by 2G. Specific energy can also be defined as the sum of depth of flow plus velocity head. So if I make the this is our this is datum head, this is the water surface, and this is the energy line. This value is Z datum head, depth of flow and velocity head. This line is called total energy line, water surface, and this is bed, channel bed. So at any section, let us assume this is section first and this is section 2. So specific energy at section 1. So at section 1 specific energy E1 can be written as Y1 plus V1 square by 2G. Similarly, at section 2 the specific energy can be written as Y2 plus V2 square by 2G. And the total energy at section 1 can be written as Z1 plus Y1 plus V1 square by 2G, and at section 2 Z2 plus Y2 plus V2 square by 2G. V2 square by 2G, where Z1 is the datum head at section 1, Y1 is the depth of flow at section 1, and V1 square by 2G is the velocity head at section 1. Similarly, Z2, Y2 and V2 square by 2G is the datum head, depth of flow and velocity head at the section 2. So now I am going to discuss the relationship between depth of flow and specific energy. Let us assume this is our curve. This is called, this axis is called depth of flow, and this is the egg line which makes an angle of 45 degree, and this is the specific energy curve, and this axis is called specific energy axis. And at a certain value of specific energy, let us assume this is E, and this is the critical specific energy EC, and the depth at the critical energy is called critical depth, and at a certain value of specific energy there are two depths. We can see at two depths where the specific energy is same, and these two depths is called alternate depth. This is Y2 and this is Y1, and this is the critical flow. At critical flow our Proud number is unity, and we can see that above the critical flow the flow is subcritical. When Y is greater than YC, Y is greater than YC, and Proud number is less than 1, then this is the property of subcritical flow. Similarly, in this region below the critical flow line, Y is less than YC. We can see that Y is less than YC and Proud number is greater than unity. Then flow is called supercritical flow. And we can see that this point is the minimum specific energy. So the at critical depth the energy is minimum, and that energy is called critical specific energy. Or critical depth is defined as the depth at which specific energy is minimum is called critical depth, and along this flow the flow is called critical flow. And if the value of Y or depth of flow is greater than the critical depth of flow, then uh, in that region the flow will be subcritical flow. And if the depth of flow is less than the critical depth of flow, then our flow is supercritical flow. So we can write here, when Y is greater than YC, flow is subcritical, and in subcritical Proud number is less than unity. Similarly, when depth of flow is less than critical depth of flow, then flow is supercritical, and in that case our Proud number is greater than unity. When y is equal to yc, flow is critical, and in this case our Proud number is unity. Similarly, we can see that at a given value of specific energy, or we can write at two depths where the specific energy is same. So at a given value of specific energy E, or the depth at which specific energy is same, that is y1 and y2, are called alternate alternate depth. Here we can see that at specific energy E, at y1, at depth of flow is y1, then specific energy is E, and when the depth of flow is y2, specific energy is same as E, then these two depth is called alternate depth. Or we can see that at alternate depths our specific energy will be same. So here we have the same thing we have I have written the depth at which specific energy is same are called alternate depth. Similarly, if I third conclusion is that the depth at which our specific energy is minimum is called critical depth. So the depth at which specific energy is minimum is called critical depth. Critical depth. So now I am going to derive the expression for the critical flow. What is the expression for critical flow? So for a given value of Q, the specific energy can be written as Y plus V square by 2G, or we can also write Y plus V is equal to Q by A, so Q square divided by 2G into A square. So for specific energy to be minimum for a fixed value of Q, dE by dy should be 0. So we can derive this expression dE by dy. So we can write dE by dy is 1 plus Q is fixed, G is acceleration due to gravity is also fixed. So we can write minus 2 by AQ into dA by dy, and this value should be 0. So if I write uh, this value 2 to cancel, so it will be Q square by GAQ, Q square by GAQ into dA by dy is equal to 1. So let us take a channel. This is our channel, and this is the normal depth of flow of the channel, and this is dy. This is the top width and elemental area dA. So we can write dA is equal to how much? T into dy. or we can write dA by dy is equal to T. So put the value of dA by dy in equation number 1. So it can be q square into T divided by G AQ is equal to 1. So this is the condition for the critical flow or condition for the minimum specific energy. So this is the condition for critical flow. So at in any channel, when the flow is critical, so we can apply this expression where Q is the discharge, Q is the discharge, A is the area of the channel, area of the channel, and T is the top width of the channel, and G is the acceleration due to gravity. So we can write Q squared T by GAQ is equal to 1, or we can also write Q square by A square into T divided by G into A is equal to unity, or Q square by A square we can write V square into uh, we can write G into A by T is equal to unity, or we can also write V square by G, and this A by T is the hydraulic depth, so we can write G into D is equal to unity, or we can write V is equal to a square root of GD, or V by a square root of GD is equal to 1. And what is this? V by square root of GD is the Proud number. So Proud number is equal to 1. So as I told you that in case of critical flow our Proud number is unity. So this is proof. So for critical flow Proud number is unity. Now I am going to discuss the relationship between specific energy and discharge. So we can see that this is the depth versus specific energy curve, and for the different discharge we have I have drawn the specific energy curve. Let us, this is for the discharge Q1, this is the specific energy curve. For Q2, this is the specific energy curve. For Q3 and Q4, and this is the specific energy curve I have taken when discharge is the maximum discharge. And we can see that for a given value of specific energy, we can see that once the we can see that the magnitude of discharge value, that is Q4 is greater uh, than Q3, then Q2, and then Q1. So as the value of discharge is increasing, the difference between intercept is decreasing, or we can see that the difference between alternate depth is decreasing. And a point at a point comes when our there is a only touches the this intercept line BP dash, or tangential to the this Q is equal to Km, and after that there is a no intercept on the discharge beyond this Q is equal to Qm. Means this is the maximum possible flow in the channel is this one. So for a given specific energy we have to uh, derive the relation. What is the relation for the maximum discharge for a given value of specific energy, that is I am going to derive. So here I have written such points. Here the magnitude is Q4 is greater than Q3, greater than Q2, greater than Q1, and is constant along E versus Y. Consider section PP dash in this plot. It is observed that different Q gives different intercepts. we can see that different q will give different, let us assume for q1, so the intercept at this point and this point, that is called alternate depths, and the value and this intercept decreases as the q increases. After that, I have drawn a specific energy curve for q is equal to qm, maximum discharge, such that qm is maximum discharge is greater than q3. This qm is greater than q3 but less than q4, and just pp dash is the tangential to the point c. Specific energy for q is equal to qm uh, represents the maximum value of discharge that can be passed in the channel while keeping the specific energy at constant value of E1. We can see that at specific energy E1, so the Q is equal to Qm is the maximum discharge at which the depth of flow, one depth of flow is possible, and after that there is a no, if I draw the different discharge curve which is greater than Qm, Q is equal to Qm, then there is a no intercept on that specific energy curve. Means this is the maximum possible discharge in a channel that is possible. The specific energy curve for Q is equal to Q greater than Qm will have no intercept on the line PP dash, and hence there will be no depth at which such discharge can pass in the channel with the given specific energy. So what is the condition for the maximum discharge in a channel for a given specific energy? So we know that specific energy is equal to y plus v square by 2g, or by we can write y plus uh, q square by, or we can write uh, velocity is equal to, here we can write E is equal to y plus velocity can be written as q square by 2g a square, or we can write E minus y is equal to q square by 2g a square. So q can be written as 2g into E minus y a into a square root of 2g into E minus y. So for maximum discharge possible in a channel for a given value of specific energy E1. So for the maximum value of discharge, what should I do? What will I do? So dq by dy is equal to 0. So if I compute the value of dq by dy, so it will be dq by dy is equal to the square root of 2g is constant. So we can write dA by dy into a square root of e minus y minus a into 1 by 2 into a square root of e minus y is equal to 0. So if I put this value is 0, so we can write dA by dy into a square root of e minus y is equal to a by 2 into a square root of e minus y, or we can write dA by dy into e minus y 2 times is equal to a, and we know that E is equal to y plus b square by 2g. We know that specific energy is equal to y plus b square by 2g. So we can write E minus y is equal to v square by 2g. Put the value of E minus y, so we can write, and dA by dy is equal to top width, so we can write 2t into 2 into t into e minus y is b square by V square by 2G is equal to A. 2 to cancel and V we can write. So T into Q square by G into A square is equal to A. So it will be Q square into T divided by G into AQ is equal to unity. So this is the condition for maximum discharge. Condition for maximum discharge for a given value of specific energy. So we have derived condition for critical flow, and we have seen that the Q square T by GAQ is equal to unity. But this condition, this is the condition for critical flow, but for a given value of discharge, and condition for maximum discharge possible, maximum discharge. So it is also Q square T by GAQ is equal to unity, and but this is for a given value of specific energy. So this is the two condition we have derived today. So today I have discussed about the condition for the critical flow in a channel for a given value of Q, and after that what is the condition for maximum discharge possible in a channel for a fixed value of specific energy. So in the next class I will discuss the what is critical depth and the expression of critical depth and expression of specific energy for different types of channel. So take care of your health and happy learning.